So in this lecture we are moving on to the disinfection, how to remove the contamination due to bacterias. Okay, so that is known as disinfection. So we are moving on to that step. So we have already seen this. There are mainly three treatments: primary, secondary and tertiary. Disinfection mainly comes under the tertiary treatment. So disinfection, you all know what is disinfection. It is the removal or killing of bacteria from water, bacteria and other disease causing organisms in water by means of some chemicals or by means of some processes. That is known as disinfection. It can be uh, otherwise named as sterilization. Sterilization means we are disinfecting by means of boiling the water. Then that process is known as sterilization. Okay, so sometimes disinfection is synonymously used as sterilization. Now, the theory behind the disinfection of bacteria is when a single unit of microorganism is exposed to a single unit of disinfectant, the reduction in microorganisms follows a first order reaction. How much rate the microorganisms in water will decrease when we are adding disinfectants. Disinfectants means the things or substances which are used for disinfection. For example, chlorine. Chlorine is the most widely used disinfectant. Okay, so when we are adding chlorine, at what rate the microorganisms, the number of microorganisms in water is reduced. Okay, that follows a first order reaction, and that reaction or that equation is given by Chick, scientist named Chick. So it is known as Chick's law, and it follows this equation: dN by dt is equal to minus k nt, where k is the disinfection constant or reaction rate constant, and t is the contact time of the disinfectant to water. N is the number of organisms, where N0 is the initial number of organisms. So finally we can write the equation as we have to integrate this equation, and finally we'll get the contact time for the disinfectant. T is equal to 1 by k log to the base 10 N0, initial number of organisms, divided by Nt, number of organisms at the time t. Okay, so this is the equation which is given by Chick for calculating the rate of decrease in bacteria or microorganisms by the addition of disinfectant. Okay, but this equation is not applicable for chlorine. Chlorine is a generally used disinfectant, but other than chlorine we can use this equation. The substances for the substances other than chlorine we can use this equation, but for chlorine the equation is slightly different. It is not given by Chick, it is given by some other scientist, and the equation is dN by dt is equal to minus k ntt. That is, he has given that the scientist who have derived this equation found out that the rate of decrease in the number of organisms depends upon or directly proportional to the contact time also. Okay, so we can finally write the equation as T is equal to root of 2 by k log to the base 10 n0 by nt. All the quantities are described above. So this is the rate at which microorganisms are decreased. Now, there are many methods of disinfection. How we can remove the bacteria? There are different methods for that. Mainly used methods are given here. Boiling. Boiling is a very simple method. Treatment with excess lime. When we are adding excess lime to the water, then it is disinfected. Treatment with ozone, iodine and bromide treatment, potassium permanganate treatment, silver treatment, UV ray treatment, and chlorination. So these are the different methods by which we can do disinfection. So we'll see each of them. First one is boiling. That is a very simple method. The bacteria present in water can be destroyed by boiling it for a long time. So when we are boiling the water for a long time than necessary, okay, there is only a short time needed for boiling of water, but we are again boiling it for a long time, then all the organisms in water will be killed. Okay, but it cannot take care of future possible contaminations. Even though the organisms in the water are killed, there may be a chance of again, what is that? Again having the presence of bacteria in that boiled water. Okay, we cannot avoid that. That is the disadvantage of boiling. second method is treatment with excess lime. Lime is generally used for water softening, because when hard water is there, we can use lime for soften the water. Okay, but when we are using excess of lime, what will happen? Lime is actually alkali. Okay, so when we are adding more and more lime, means the alkalinity of water is increased. So the microorganisms in water cannot survive in much alkaline water. Okay, so when alkalinity increases, the organisms will be killed, the disease causing organisms will be killed. So that is the principle of this. And when we are adding lime in a large amount, we have to remove that lime after disinfection. Okay, after disinfecting the water, we have to remove, we have to do some technologies or implement some technologies for removing the excess lime which was added to the water. Okay, so recarbonation is one of the method for removing the lime which is used for disinfection. Third one is ozone treatment with ozone. You all know that ozone is O3. Okay, it contains a nascent oxygen as well as a oxygen molecule, O2 plus O. O is known as nascent oxygen. Okay, so this nascent oxygen has the capacity to oxidize. Okay, it is a powerful oxidizing agent. It has the ability to kill bacteria. So when ozone is added, it will dissociate into nascent oxygen as well as oxygen, and the nascent oxygen will disinfect the water. That is the principle. Fourth one is treatment with iodine and bromide. They both are halogens. So iodine and bromide, when they are in contact with water for 5 minutes in a quantity of 8 ppm, then it can disinfect the water. Okay, so this much time is needed and this much quantity is needed. When they are applied in such a quantity, in such that much time, then water is get disinfected. Mainly this bromide is used in swimming pools and all. Disinfecting water in swimming pools, we will use bromide, because it will not cause any irritation to our eyes. So we can add bromine in that cases. Another one is treatment with potassium permanganate. It is also a powerful oxidizing agent. When it has the power of oxidizing, then it can kill the bacteria. So it is mainly used for cholera bacteria only. So it is very effective for cholera bacteria. Other bacteria, it is not much effective. So when it is applied in a quantity of 2.1 ppm for a period of 3 to 4 hours, it can kill cholera bacteria effectively. Next one is silver treatment. So treatment with silver is another thing. Silver is also a disinfectant. In case silver, you all know that silver is a metal. Okay, so it is used as a filter normally. Okay, a filter is made with silver and water is allowed to pass through the filter. So when water comes in contact with this filter, some amount of silver react with the water and it will cause disinfection. That is the principle. When the silver is applied in 0.05 to 1 ppm for a contact time of 15 to 3 hours, 15 minutes to 3 hours, then it can effectively disinfect the water. But you all know that silver is very costly, so its application is very much limited. Another one is UV ray treatment. So you all know that ultraviolet rays are a very good disinfectant when it is allowed to pass through water. It is mainly used in pharmaceutical, food and beverage, chemicals, drugs, etc. And that is a principle. The eighth and final one is chlorination, which is the very common method of disinfection. It is the important and very common method, which is a very cheap and easy method. Okay, the principle behind this chlorination is enzymatic hypothesis. Okay, that principle is known as enzymatic hypothesis. Actually, what the principle is, chlorine, when it is applied to water containing bacteria, the chlorine will enter into the cells of the bacteria. Okay, first it will enter into the cells of the particular disease causing bacteria, and it will uh, kill the enzymes. There may be some enzymes in that bacteria, so it will kill all the enzymes in that which are essential for the metabolic processes of that particular bacteria. So what will happen? It cannot do any processes and it will die by itself. That is the process happening when we are adding chlorine to water, and it is a common disinfection method. So we will discuss more about chlorination. So why chlorine is used? We can use many other things, but why we are using chlorine? Because chlorine is highly soluble and easy to apply, very soluble in water, Second thing is chlorine is readily available as gases, liquid or powder. It can be available in any form. We can use it in any form. Chlorine is toxic to most of the microorganisms. Okay, it is not specific to some kind of organisms. It is used for killing all kind of microorganisms. And chlorine treatment is cheap and reliable. It is very cheap and reliable. It produces desired effects which last for a long time. Long time disinfectant. Okay. So because of all these reasons, we are using chlorine commonly. And what are the properties of chlorine to be used as a disinfectant? The chlorine is discovered in 1774 by a scientist known as Scheele, but it was named as chlorine by Davy, a scientist known as Davy in 1810, and he has established it as an element. Okay, actually, chlorine is added to the periodic table in 1810 by Davy. Okay, and its symbol is Cl. You all know that. Atomic weight is 35.46 gram. It is 2.49 times as heavy as air, and it is very soluble in water to the extent of 4.61 volumes in 1 volume at 0 degrees Celsius. When we are allowing the chlorine to dissolve in water at 0 degrees Celsius, we can dissolve almost 4.61 times chlorine into water. Okay. And when the temperature is very low, chlorine water will form crystals. And when the temperature is very high, or when it is exposed to sunlight, the chlorine will get decomposes. Okay, so that is the main property of chlorine. And the gas, when it is available in gas, it is in yellow color, greenish yellow color, and having a pungent odor which is irritating to our nose and lungs. And it is not combustible, but it support combustion, and it is chemically active, and when it is in contact with moisture, it will cause corrosion to metals. Regarding the dosage of chlorine, we will mainly normally apply 0.2 ppm to 1 ppm of chlorine. When excess chlorine is applied, it will cause a bad smell in water. So you all know that. You may have faced the situation when chlorine is in excess in water. And we have to give a contact time of 1 to 4 hours for proper cleaning or disinfection of water. Uh, Organic matters, sulfides, nitrates, iron, etc. present in chlorine. If the other organic matters, fluorides, sulfides, nitrates, etc. are present in water, then it can have an ability, it will have an ability to destroy this chlorine. Okay, so we cannot apply chlorine to a water having this kind of matters. And temperature also affects chlorination. When there is no much temperature, then it will delay the disinfection process. And if suspended matter is present in the water, then it can heal the bacteria, okay, without making it in contact with chlorine. Okay, when suspended matter is there, we have to remove the suspended matter first, and after that only we can do the chlorination. Otherwise the bacteria will be healed by the suspended matter, and proper disinfection will not take place. Now we will move on to the action of chlorine. When we are applying chlorine to water, what are the actions or reactions occurring in water? So first, you all know that chlorine is Cl. When Cl2 is applied into water, Cl2 plus water will give HCl plus HOCl, where HCl is hydrochloric acid and HOCl is hypochlorous acid. This hypochlorous acid will be converted to hydrogen plus OCl, that is hypochlorite acid. So HOCl will be reversibly converted to H plus OCl, hypochlorite ion. So this hypochlorite ion and hypochlorous acid both are responsible for disinfection. Both has the ability to destroy microorganisms. So it also the chlorination process also depends on pH. Disinfection mainly occurs when the pH is below 7. Okay, it will occur mainly in acidic pH. And a term known as free available chlorine is there. It is the sum of hypochlorous acid, hypochlorite ion and molecular chlorine if available in water. So all these together is known as free available chlorine. And we have to apply chlorine in different means. There are different means of applying chlorine. Mainly there are three means. One is as bleaching powder, Bleaching powder is a product of chlorine, and chloramine, it is another product. Free chlorine gas is also there. So we can apply all these products into water, okay, if necessary. First one is bleaching powder. The scientific name of bleaching powder is calcium hypochlorite, CaOCl twice, which is a white colored powder having a smell. Okay, when it is added to water, what is happening is it will dissociate. It will get dissociated into calcium and hypochlorite ion. You all know that this hypochlorite ion has the ability to kill bacteria. Okay, so and this is again unstable, so it combines with hydrogen ions present in water to form hypochlorous acid also. So that process is known as hyperchloration. So both these hypochlorous acid as well as this hypochlorite ion will kill all the bacteria in water. So this is the process happening when chlorine is added to water, or bleaching powder is added to water. And bleaching powder contains 30 to 35% of chlorine. Normally 0.5 to 2.5 kilogram per million uh, liters of water will be applied. Okay, that is the dosage of bleaching powder. Second product is chloramines. Okay, chlorine can be applied by combining it with ammonia. That is known as chloramine. Chlorine mixed with ammonia. So we have to apply, we can apply this product also for disinfection. So first we will apply chlorine. When chlorine reacts with water, it will give us HCl and HOCl, hypochlorous acid. Again, then we will mix ammonia to that. When ammonia is mixed, it will combine with this hypochlorous acid to form monochloramine first. Then this monochloramine again reacts with hypochlorous acid to form dichloramine. This dichloramine again reacts with hypochlorous acid to form nitrogen trichloride. All these products can kill bacteria. All these products have the ability to kill bacteria. Okay. So, this monochloramine will disinfect bacteria effectively at pH greater than 7.5. Dichloramine kills bacteria effectively between a pH of 5 to 6.5, and nitrogen chloride kill bacteria below pH 4.4. So all these are effective disinfectants. And the ratio of ammonia in water is given here. This is the dosage of ammonia. And the final product is as a free chlorine gas. Directly we can give the chlorine gas into water. So either we can give directly into water, or we can give it as a solution. So when it is given as a solution, we will liquefy the chlorine by applying pressure. 0.7 Newton per millimeter square pressure is when applied into chlorine gas, it will be converted to liquid. So that liquid is used for chlorination. There are two instruments or apparatus which are used for regulating the quantity of chlorine to be added in water. That instruments are known as chlorinator or chloronome. Okay, it is otherwise known as chloronome. So this instrument is used to restrict the quantity of chlorine into water. So these are the different products which we are using for applying chlorine into water. Now there are different forms of chlorination. Plain chlorination is there, pre-chlorination, post-chlorination, double chlorination, breakpoint chlorination, superchlorination and dechlorination. We will just see what are the terms. Plain chlorination means we are just applying chlorine to water. Okay, we are just applying plain chlorine to water for killing algae and remove bacteria. That is known as plain chlorination. Not any product like bleaching powder or chloramines we are not applying. We are just applying chlorine. Okay. Pre-chlorination means before doing any treatment to water, that is screening, before doing sedimentation, before doing coagulation, we are applying chlorine. Then it is known as pre-chlorination. Post-chlorination means we are applying chlorine after all the other treatments. Okay, we are disinfecting the water after all the other treatments have done. Okay, that is known as post-chlorination. Double chlorination means we are applying two times chlorine at two times, when while starting the treatment as well as while ending the treatment. So at 2 points we are applying the chlorine. Then it is known as double chlorination. These are just terms. Breakpoint chlorination is there. When we are applying chlorine, we have to know the particular quantity to be applied. Okay, if we don't know the quantity, then we will apply chlorine as our wish. Okay, so the chlorine we are applying, first it will kill the bacteria. When it kills all the bacteria, then it starts to deposit as residue. Okay, so that particular point is known as break point chlorination. So we have to apply sufficient amount of chlorine. When it is sufficient, that particular point is known as break point chlorination. Superchlorination means we are giving excess amount of chlorine than the break point. It is known as superchlorination. And dechlorination means we are removing the chlorine from water. That process is known as dechlorination. So these are just the terms related to chlorination. And finally, there is one other product, chlorine dioxide is there. It is more effective in removal of bacteria than chlorine, plain chlorine. So it is also a disinfectant. Its dosage is 0.5 to 1.5 ppm, and it will affect the bacteria effectively between the pH of 6 to 10, and it is used for water with having high alkalinity, but it has very high cost. It is also used as an effective disinfectant. So this is about disinfection. Thank you.